Let us start polynomials. Polynomials. So all of us are comfortable with the idea of algebraic expressions, right? We have studied about algebraic expressions in our junior classes. Polynomials are special kind of algebraic expressions. Special kind of algebraic expressions where the variable powers of variable are whole numbers, right? Or you can say non-negative integers. Non-negative integers. So if I have to say a definition for polynomials, these are just the algebraic expressions with non-negative integral powers of the variable. Okay, for example, if I have got, let us say, x cube plus 2x square plus 5, this is a polynomial. This is a polynomial because powers of variable, that is x in this case, are whole numbers. 3, 2, or 5 can be written as 5 into x raised to power 0. So 0 is also acceptable. But negative powers, fractional powers, etc. are not acceptable. For example, if you have to comment on x plus 1 by x, is this a polynomial? No, it is not a polynomial because this x here has got negative power. Okay, so this is not a polynomial. This has got negative power because this can be written as x plus x raised to power negative 1. So this is not a polynomial because the powers of variable in this case are not non-negative integers. Okay, now highest power of variable is given a special name, that is degree of polynomial. Degree of polynomial. For example, in this polynomial, what was the highest power of x? It was 3. So if I have to comment on the degree of this polynomial, I can say the degree of this polynomial is 3. Alright, now polynomials can be categorized broadly on the basis of number of terms, and another way is highest power of the variable. Highest power of variable. When I say number of terms, for example, if I write x plus 2, right, it has got two terms, 1, 2, right? These terms are separated by this plus sign here. They could have been separated by negative sign. So these terms are separated by plus or minus sign, right? And each term has got a different power of x. What do I mean is, if you write, let us say, another polynomial, 3x square plus 2x plus 5, how many terms has it got? 1, 2, 3. So it has got total 3 terms. Okay, now all these 3 terms are separated by these plus signs. If I write 5x square minus 2x square plus 2x plus 5 and somebody thinks that these are 4 terms, then he will be wrong. Why? Because these 2 terms are alike, because power of x in these 2 terms is 2. So you have to club the like terms, and then say something about the number of terms. So number of terms in this case also is 3. Okay, now, so basis of number of terms you can categorize the polynomials, or on the basis of highest power of the variable in a polynomial you can categorize a particular polynomial. Let me clear the board. So on the basis of number of terms, let us say a polynomial has got 1 term, 2 terms, 3 terms, 4 terms, and so on. If the polynomial has got only 1 term, for example 3x square, 5x, 9x raised to power 9, or simply I can write 5, right? Such polynomials are known as monomial, right? I am just categorizing the polynomials on the basis of number of terms only. So if it has got two terms, for example 3x square plus 5 or 5x plus 9, or you can make any other polynomial, 9x raised to power 9 plus 5x square, right? All these polynomials that I have written here have got two terms. Such polynomials are known as binomial. So if a polynomial has got three terms, for example 3x square plus 5x plus 9, it has got three terms. Such polynomials are known as trinomials. Okay, and for the powers higher than, or for the number of terms more than 3, all other are collectively known as polynomials. That doesn't mean that these three are not polynomials. All of these are polynomials, whether they have one term, two terms, three terms, or more than three terms. It's just that these three are given some special names like monomial, binomial, and trinomial. Another way of categorizing the polynomials is on the basis of highest power of x. Highest power of x, right? If the highest power of x is 0, 1, 2, 3, and so on, we can name them as different polynomials. For example, if the highest power of x is 0, what kind of case that would be? Let us say I've got 5, right? 5 can always be written as 5 into x raised to power 0, because x raised to power 0 is nothing but 1, or 6, or 7. So these constants have got highest power of x as 0. Okay, and for highest power of 1, I can take examples like 5x, 7x, and so on. Okay, so highest power of x in these cases is 1. Okay, another example is, let us say 9x plus 3. Highest power of x is 1. So if the highest power of x is 0, these polynomials are known as constant polynomials. If the highest power of x, and we have got a special name for highest power of x, that is degree. I have already defined it. So if the degree of a polynomial is 1, then I would say it is a linear polynomial. It is a linear polynomial. If the degree is 2, then it is known as quadratic polynomial. If the degree is 3, it is known as cubic polynomial. Right? In the similar fashion, I can say if the highest power of x or the degree is 4, it is known as biquadratic polynomial. Biquadratic polynomial. Okay, so these are broad categories of polynomials, okay, based on highest power of x or the number of terms. Now the next thing that we need to learn here is value of a polynomial. Value of a polynomial. Before going to value of polynomial, if I have to write a constant polynomial, a general constant polynomial, I can write any arbitrary constant like this, a, right, or c. So this is a constant polynomial. If I have to write linear polynomial, the general way to write it is ax plus b. Okay, quadratic, the general quadratic can be written as ax square plus bx plus c. Okay, so these are constants. A, B, C are constants. Highest power of x is 2, right? So this is general quadratic. So you can write cubic like this, ax cube plus bx square plus cx plus d. Okay, now if you have to find the value of a polynomial, it means that if I say, let us say ax plus b is a polynomial, okay, and I need to find the value of this polynomial at x equal to 1. So what will be the value? I will simply put x equal to 1 and it will give me a value a plus b. Okay, now to denote these polynomials, I can use these kind of expressions, f of x, p of x, g of x. These kind of expressions will be used. That means function of x. This also means function of x. What does it mean is, let us say I write f of x is equal to ax plus b. It means this is function of x. It will change its values as x changes its values. So if I write f of 1, it will give me a value a plus b. If I write f of 2, it will give me value 2a plus b. Right? I will keep on replacing x with these numbers. Right? So if I need to find f of 3, it will give me 3a plus b. So these are the values of this polynomial at various values of x. Okay. Now when I say that this is a quadratic expression, what if this a becomes 0? Then this complete term will vanish, right? This will no longer be a quadratic. So whenever we write general expression for a quadratic, cubic or anything, we need to define that this coefficient of the highest power of x is non-zero. So a is non-zero in this case. A is non-zero in this case for it to be a cubic, for it to be a quadratic, for it to be a linear, right? We will generalize this polynomial in a moment. Okay, before that, let us cover value of a polynomial. So if I give you 3x square plus 5x, right, and I write it like this, p of x. So what will be p of 1? P of 1 will be 3 into 1 squared plus 5 into 1, that is 3 plus 5, which is equal to 8. So if I ask you p of 2, you will just replace x with 2 everywhere, right? So it will give you, this is 4 into 3, 12 plus 10, that is 22. So the value of this polynomial at x equal to 2 is 22, right? Now let me clear this page. If I write a general quadratic like this, f of x is equal to ax square plus bx plus c, where a is not equal to 0, and I am supposed to find f of 1. So what will be f of 1? It will be a 1 square plus b into 1 plus c, that is a plus b plus c. Okay. What will be f of 2? It will be equal to a 2 squared plus b into 2 plus c, that is 4a plus 2b plus c. In the similar way, you can find various values. Let us say f of 1 by 2. So you will write 1 by 2 in place of x, and you will get the value like this, a by 4 plus b by 2 plus c. Okay, so these are some of the values of polynomials. What is the significance of these values? Let us say, let me clear the board. Let us say I write a polynomial f of x equals 3x plus 2. Okay, now if I put x equal to 1, f of 1 is equal to 5. If I put x equal to 2, f of 2 is equal to 8. Now what is the significance of it? It is very significant because we can draw it on a graph, right? So we take x values on the x-axis and f of x values on the y-axis, right? This is basically the independent variable, and these are the values of dependent variable, right? That is f of x, because its values are dependent on values of x. If x changes values, it will also change its values accordingly. So x values are to be denoted on x-axis, and accordingly the f of x values, or we can call it y also, right? Because this will be denoted on this vertical axis, y-axis. So y equal to 3x plus 2, it means when x is 1, y is equal to 5. That is this point. and this point can also be written in the coordinate form as 1, 5. Another result that we got was x equal to 2 gives me y equal to 8. So let us say y equal to 8 is somewhere here, and 2, 8 will be this point here, 2, 8. Now if you join these points, what kind of graph do you get here? You get a straight line graph, right? So this expression was a linear expression, that is first degree expression, and graph of this linear expression is a straight line. That is why it is called linear expression, okay, because its graph is a straight line. Okay, now if I have to draw, let us say f of x, or you can say y equals ax square plus bx plus c. Okay, now let us say this is x-axis, this is y-axis. So if I have to find f of 0, okay, so what will be it? X can be replaced with 0, it will be equal to c. All right, f of 1, that is a plus b plus c. So when x is 0, y is c, okay, and when x is 1, y is a plus b plus c. So whatever value, let us say the graph is something like this. When you have got a quadratic expression, the graph is a parabola. I will just cover it in this lecture itself, but let me, for this example, let me draw a rough graph. When I say f of 0 equal to c, I mean where x is 0, right? What is the value of y? This is the value of y here, corresponding value. Now this value is c, or if I have to write the coordinates of this, I can write 0 comma c for this point. Corresponding to 1, I have got y value, this, right? And what is this value? This is a plus b plus c. So this here is a plus b plus c. Okay, so if I have got a graph, any graph, let us say I have got any graph, okay, and I have got this point. Now if you look at this axis here, at this horizontal axis, that is x-axis, this point is the value of x that I am putting in the polynomial, and when I look at the y-axis, this will give me the value of polynomial, that is f of x. If this is x, then this is f of x. Okay, for this, let us say this point is a here, then the corresponding y value is here, that is f of a. Okay, so the values of polynomials will be there on the vertical axis, and values of x will be on horizontal axis. Okay, so if let us say y is equal to 0, what does it mean? On the x-axis we know y coordinate is 0. So when y is equal to 0, it means every point on x-axis has got y coordinate as 0. That means y equal to 0 is x-axis itself. Okay, another thing that we noticed is that a linear polynomial, graph of linear polynomial, cuts the x-axis at one point only. It cuts the x-axis at one point only. Similarly, graph of quadratic polynomial cuts the x-axis at 2 points at max, right? It cannot cut the x-axis at 3 points. Maximum it can cut at 2 points. Okay, so let me cover these fundamentals in the next lecture, because this will become very lengthy then. Okay, so let us pause for a moment.